Alright, next we're going to learn about how to tell if a reaction is a redox reaction or not. So what does it mean to be redox? Redox stands for reduction oxidation. So reduction means that we have a reduction in our oxidation number. So our oxidation number decreases. In order for our oxidation number to decrease, we have to gain electrons. Oxidation means that our oxidation number increases, which means we have lost electrons. There's some ways you can remember this. One is, excuse me, Leo the lion goes grr. Lose electrons oxidation, gain electrons reduction. Another is oil rig. Oxidation is loss, reduction is gain. Either of those are good ways to help you remember. Alright, so how do we know if a reaction is redox? In order for it to be a redox reaction, you must have both oxidation and reduction. Just like anything, everything has to be conserved. So if you have a reduction, right, if we have a gain of electrons, those electrons had to come from somewhere. So they had to be lost from something. They couldn't just appear out of nowhere. Okay, so something had to lose in order for something else to gain. So you have to have both something to oxidize and something to reduce. Right, and so in order to know that, well, we have to assign oxidation numbers. Alright, and so here in this example, we have aluminum. It's an element, so it has an oxidation number of 0. Alright, here, sulfuric acid, hydrogen, always a +1 when it's in a compound. Oxygen, always a -2 when it's in a compound. Well, now we got to figure out what's sulfur, right? Well, our hydrogen, we have 2 of those. So that makes +2. We have 4 oxygens. Each of those is -2, so that makes -8. So what's that sulfur got to be? Because that's got to add up to 0. So -8 and +2 makes -6. So that's got to be a +6. So sulfur's a +6. Alright, so then over here, we got aluminum. Well, aluminum's in group 3, and it's in a compound, so that's going to be +3. Right, oxygen's a -2. Right, this is still sulfate. Right, over here with sulfate, I'll give you a tip. Polyatomic ion stays the same. That sulfur, its oxidation number is going to stay the same because that's the same polyatomic ion it was before. So that oxidation number is going to stay. Then over here we have hydrogen. That's the element form of hydrogen, right, because it's diatomic. So it's going to have an oxidation number of 0. So let's look and see. Aluminum went from 0 to +3. Its oxidation number increased. So that means it oxidized. Well, then hydrogen went from a +1 to a 0. Its oxidation number decreased. So it underwent reduction or was reduced. So we have something oxidized and something reduced. And so this is a redox reaction. Okay? We also know this to be a single replacement reaction, right? Remember, we called this before a single replacement reaction. Alright, let's look at another example. Before we called this kind of reaction what? 2 compounds make 2 compounds, right? Before we called this double replacement. But is it redox? Well, let's look and see. Let's assign oxidation numbers. Aluminum, it's in a compound, it's in group 3, it's +3. Sulfur and sulfate, we already know that one from up here, +6. Oxygen's always -2. Hydrogen, that's always a +1. Oxygen's always a -2. Let's figure out nitrogen. Well, since hydrogen's a 1, oxygen's a -2, there's 3 of those, so 3 times -2 makes -6. That makes nitrogen. It's got to make that add to 0. So positive 1 and negative 6 make negative 5. So nitrogen's got to be a plus 5. So nitrogen's a plus 5. Over here, aluminum, still in group 3. So that's still plus 3. Oh look, we still got nitrate, right? That means nitrogen's still plus 5. Oxygen's always at minus 2 in the compound. So over here we got hydrogen, still plus 1 in a compound. I still have sulfate, right? So that sulfur is still 6. And that oxygen's still minus 2. So aluminum, 3, 3. Sulfur, 6, 6. Oxygen, 2, 2. Hydrogen, 1, 1. Nitrogen's 5, 5. Oxygen's 2, 2. Nothing changed. Nothing oxidized, nothing reduced. This is not redox. Right? So look here, double replacement reactions, if you recall, only it happened when the ions trade places, right? And we still write the formulas based on the charges of the ions. So the charges didn't change. And so the oxidation number, remember, is just the charge. So guess what? It's not redox because it doesn't change. Let's look at another one. Isn't the element sodium plus the element chlorine makes a compound sodium chloride? Before we called this synthesis, right? Well, sodium's an element, its oxidation number is 0. Chlorine's an element, it's diatomic, still an element, 0. Over here, sodium's in group 1, right? So that's a plus 1. Now since sodium's plus 1, that means chlorine's got to be what to make that 0, right? Minus 1. Well, let's see what happened. Sodium went from 0 to plus 1. Its oxidation number increased, so it oxidized. Right? Chlorine went from 0 to minus 1, so its oxidation number decreased, and so it reduced. Look at that. We have a redox reaction because we have something to reduce, something to oxidize. Right? So a synthesis reaction because its oxidation number changed. Alright, what did we call this type of reaction before? Right, carbon-hydrogen compound called a hydrocarbon plus oxygen makes carbon dioxide and water. Right, we called this combustion. But is combustion a redox reaction? Well, let's look and see. Hydrogen, remember, plus 1. Let's see, what's the oxidation number for carbon? We have 4 hydrogens, so that's going to be plus 4. Now here we have 2 carbons. Remember, we assign oxidation numbers for 1, right? So both of those carbons together have to be a minus 4, right? So what's 1 carbon, right? 1 carbon's going to be a minus 2. Oxygen, that's an element oxygen, so that's 0. So over here, this carbon's is in a compound, and so that's minus 2. There's 2 of them, so that makes minus 4. So that carbon is plus 4. Right? Over here, oxygen in the compound, minus 2. This hydrogen in the compound, plus 1. Well, let's see what happened. Carbon went from negative 4 to positive 4. So that went up, right? An increase, remember, is an oxidation. Right? Let's see what else happened. Oh, oxygen went from 0 to minus 2. That went down, so that's a reduction. So we had a redox reaction. So combustion is also a redox reaction. Look at that. Now we have, what kind of reaction was this one before? Compound breaking up into elements. Right, decomposition. Well, let's see if it's redox. Well, here we have oxygen, minus 2, calcium, plus 2. Calcium here is all by itself, that's the element, so it's 0. Oxygen's the element, so it's 0. Calcium went from 2 to 0. That's a decrease, so that's a reduction. Right? Here, oxygen went from negative 2 up to 0. And so that's an oxidation, right? So we had a redox reaction. So of the 5 types of reactions we learned before, right, 4 of them are really redox reactions, right? The only one which is not is double replacement. But we did have a different name for double replacement as well. When those reactions occurred, if you remember, we called those precipitates, right? Precipitation reactions. They form precipitates. Right, so that's how we tell if we have a redox reaction or not. Right?